Okay, so now we will begin the multiple choice portion for chi-squared hypothesis testing. Number 1, our first scenario. The manager of a high school cafeteria is planning to offer several new types of food for student lunches in the following school year. She wants to know if each type of food will be equally popular so she can start ordering supplies and making other plans. To find out, she selects a random sample of 100 students and asks them, which type of food do you prefer? Asian food, Mexican food, pizza, or hamburgers? We're given a table, and number 1, question 1 asks an appropriate null hypothesis to test whether the food choices are equally popular is D. We know it's D because A is incorrect. We're not using means. B is incorrect. It has more to deal with than just Asian food. C is incorrect because N isn't the right format that we follow. And E is incorrect because it uses p-hat, which would say that it's like parameter instead of proportions, just p, which is what we want. All right, number 2. The chi-squared statistic is A. Our answer is A because if you recall, our chi-squared statistic follows observed minus expected squared over expected. B is incorrect. It follows the format expected minus observed over observed, which is kind of odd. C doesn't include the squared. D uses the wrong denominator, and E looks like it's using proportions. Now we can move on to number 3. Sorry. There we go. Okay. Number 3 says the p-value for a chi-squared test for goodness of fit is 0.0129. Which of the following is the most appropriate conclusion? Our answer is C. A says that the choices are equally popular, which would be like using our null hypothesis, which is incorrect. For choice B, the conclusion isn't right. There is enough convincing evidence since we rejected the HO. And D and E are incorrect because we rejected, not failed to reject. So C is our correct answer. Number 4, new scenario now. Number 4 reads, the National Longitudinal Study of Adolescent Health interviewed a random sample of 4,877 teens in grades 7 through 12. One question asked was, what do you think are the chances you will be married in the next 10 years? So they give us a two-way table, and our question is, which of the following would be the most appropriate type of graph for these data? Our answer is D. It's not A because it doesn't say anything about gender. It's not B because it doesn't say anything about the opinions of marriage. C and D are kind of similar, so we'll come back to that. It's not E because a dot plot wouldn't show the differences. So back to C and D, they're pretty similar, but our answer is D because our question was whether or not there's a difference between gender and opinion, not a difference between opinion and gender. Now on to number 5. The appropriate null hypothesis for performing a chi-squared test is C. There is no difference between the distributions of female and male teenagers' opinions about marriage in the population. It's definitely not D or E because this is not a test of independence or association. And it's not A because that's not the null hypothesis. So again, B and C are pretty similar, but it's not dealing with the sample, it's dealing with the population as a whole. So next one, number 6, the expected count of females who respond almost certain is expected counts If you recall, to calculate expected counts, it would be row total times column total over the table total. So in this case, our row total, which would be the almost certain row, that equals 1930. And then we multiply that by our column total. This column, which ends up being 2625. Put that all over our table total, which it did state in the beginning of the problem was 4877. So once we solve for that, our answer is D, 1038.8. All right, number 7. The degrees of freedom for the chi-squared test for this two-way table are, so these are all of our observed counts, so we'll plug all of those into the calculator using the matrix function to find our degrees of freedom. So turn the calculator on. There we go. So we'll go into matrix, hit second matrix, scroll all the way over to edit letter A, and then here is where you enter your rows and columns. I'm pretty sure it goes by columns, then rows. So we have 5 columns and 2 rows. So go ahead and enter all of your data. All right, now we'll go to stat. Scroll all the way over to tests, and then down, down, down until we see the chi-squared. In this case, we'll be using chi-squared test. This is used for both homogeneity and independence, and goodness of fit has its own little thing. So we'll use letter C. Enter, 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 and there we go. We have all of our things. So it gives you the test statistic, the p-value, and degrees of freedom, meaning our answer is A. Number 8. For these data, chi-squared equals 69.8 with a p-value of approximately 0. Assuming the researchers used a significance level of 0.05, which of the following is true? For number 8, our answer is A. A type 1 error is possible. It is only A that's correct because if you recall, a type 1 error means that we rejected the HO when it was actually true. Alright, for exercises 9 through 11, choose the appropriate chi-squared test to use. Number 9. A company claims that each batch of its deluxe mixed nuts contains 52% cashews, 27% almonds, 13% macadamia nuts, and 8% Brazil nuts. To test this claim, a quality control inspector takes a random sample of 150 nuts from the latest batch. The one-way table below displays the sample data. Alright, given the situation, choose the appropriate chi-squared test to use. In this case, it is a chi-squared test of goodness of fit because we are seeing how well our distribution matches the company's distribution.